We're on lesson 2 of chapter 5, which is on parallel and perpendicular lines. First, we're going to identify congruent angles formed by transversals. Then we'll find measures of angles formed by transversals as well. What is a transversal? A transversal is a straight line that crosses two parallel lines, and I color-coded these to help you a little bit. The parallel lines are these blue ones here that are running at the exact same angle as each other, meaning that if these went on for eternity, they would never cross because they're going at the exact same direction. So same things with these two and these two. The transversal then is the one that crosses these. It could be at any angle. It could be going this direction or straight or really at an angle. That does not matter. What matters here is the angles that these transversals create. Because these parallel lines are going at the same direction, you're going to notice a lot of similarities between the angles created here and then the angles created here by the transversals, where the transversal crosses the parallel lines. For example, you'll notice that this purple angle here and this purple angle here look pretty much the same size, except, upside down and flipped. And that's because they are. Same thing with this one and this one. These are called alternate interior. So the inside of the parallel lines, the alternate or the opposite side of the inside would be the same exact angle measure. Same thing over here. This angle and this alternate interior angle would be the same. We also see that on the exterior or the outside of the parallel lines, this blue and this blue are very similar because they're exactly the same. And then this pink one and this pink one are the same. That's called alternate exterior. So you have the two exterior ones on the alternate sides are the same measure. And then also we see corresponding. And what that means is it's color coded here, if that helps. The pink with the pink. So the top left would be the same as the top left, the bottom left, the bottom left. The top right would be the same as the top right, and the bottom right the same as the bottom right. And the neat thing is, I could give you this angle measure, for example. And the great thing is you can give me one angle measure. For example, if you said this was 110, I could find all the other angle measures in this transversal diagram here. I know that the vertical angles, as we learned last lesson, are 110. I also know that alternate exterior angles are the same, so 110 and this exterior one. I also know that corresponding one, so top left, top left. I've already found half of them. And now since I know supplementary angles make 180 degrees, I know that this one would be 70, because 70 plus 110 is 180. And guess what? I can do the same exact thing. 70. Corresponding would be top right. And then alternate exterior would be 70 and 70. Because these lines are parallel, it makes all this possible. Let's try a couple problems. First, it says measure the angles formed by the transversal and parallel lines. Which angles are congruent? So for this, you can get out your protractor and you can line this up to actually measure the angles. So I have the center point right here. If I line it up right on the angle, I can find angle 1. Angle 1 looks to be 40 degrees. So I'm going to write 40 degrees for angle 1. What's angle 2? I would see that this is an obtuse angle, so it should be larger than 90 degrees. So I'm going to put it up to here. And it looks like it's going all the way to 140. It's a little tough to see from your angle, I'm sure. So I'd make angle 2 140. Now I need to find angle 3 and 4. So I'm going to put this protractor away and give my upside down one. And we could do the same thing. Angle 3 is a large angle. As you can see, it's obtuse. So if I line it up, and we see starting at 0 here, it goes all the way to 140. If we do that for angle 4, I see that angle 4 is acute, so it's smaller. That just takes me to 40. And if you notice, there's a pattern emerging. Let's check out 5 and 6. So I'll use my upright one. Angle 5 will be right on that 40 again. Then angle 6 is 140. By now you're probably just hoping I stop doing this and actually just write the numbers down because it's getting pretty easy. But angle 7 will do that too. That's an obtuse angle which takes me to 140. And then angle 8, line up perfectly here, and that also takes me to 40 degrees. So we see everything that I just mentioned before, that we have all these different relationships. You have the vertical, corresponding, the alternate interior, the alternate exterior, that all goes true in these numbers too. I have the alternate exteriors of 140, 40 and 40, corresponding 140, 140, 140, 140, corresponding 40s, and also alternate interiors are the same as well. And then if you look at the vertical angles, those also have a relationship. So let's put that into practice here. So in the figure, line A is parallel to line B. That's what the symbol means. Find the measure of each angle. Justify your answer. So we can do this now, knowing all the relationships. For example, I know that this angle is vertical to this one, which makes it the same, so 74. I also know that there's corresponding angles, so I have the left one over here would match up with the left one over here. I also know that alternate exterior, if you go to these two, alternate exterior would be the same, so that'd be 74. And now I could find angle 1 by doing the supplementary method. I know that 74 plus angle 1 equals 180. Subtract 74 from both sides. So 180 minus 74 would be 106. So angle 1 is 106. Then I can do vertical angle with angle 3. So 106 here. And then I can do corresponding 1 and 5, or both the bottom ones here. Then I could do alternate exterior, opposite exterior for angle 7. So therefore I can answer all these questions. Angle 4 equals 74 degrees. Angle 3 equals 106 degrees. And then angle 5 equals 106 degrees as well.